Okay, let's examine the next questions. It says Henry designed and simplified a hydroelectric power station by connecting a water storage tank to a generator as shown. So this is the water storage tank. When he pulled the handle, because when he pulled this right upright, so this one will be lifted up. So water will rush down, correct? So you try to visualize this. Water will rush down inside. Because when the handle, when the cap is being released, pull up, okay, water flow down the pipe. So this is the water pipe. Okay, the turbine rotate. Okay, the turbine in this thing, the turbine rotates and activated the generator. So some students who joined my class earlier, I have shown them the video clip how the turbine works. Because the turbine is fixed with many permanent magnets. When the turbine rotates, the magnets spin around the wire, electricity is produced to the generator. Okay, the generator will convert kinetic energy of the spinning magnets to electrical energy. So they ask you complete the box to show the energy conversion when the handle was pulled. Okay, so this one quite simple. I write in short form, but you spell the whole thing. So this one, because it's at a great height, right, is GPE, so gravitational potential energy, is changed to kinetic energy of the turbine, and it's changed to electrical energy. Okay, but you spell the whole words, this part. Gravitational potential, kinetic, electrical. Okay, I put a hint here. This one is to help you to answer part B. Okay, some school taught you kinetic energy has a formula. It's half multiplied by the mass. Okay, multiply the mass. So this first line is mass. And speed times speed. Actually, it's velocity, but you haven't learned the word velocity. So I use the word speed. Okay. So it's actually half mv squared. The v is velocity. So you enter this word is mass. So kinetic energy is half times mass times the speed of the object times the speed again. Okay, that means you learn the mathematical symbols called square, right? So it's half ms squared or half mv squared. So now I say without changing the turbine and generator, suggests two ways you can redesign so that more energy can be produced. So you look at this thing. I want to increase the kinetic energy of the water that flows down. So one of the suggestions is what? Okay, actually another way without using this formula, just now we studied GPE, right? I can make this higher, right? So the first suggestion is move the storage tank higher. Okay. Second one is I want to increase more water, right, flowing through, because if we increase more water, the mass of water will increase. So how to increase more water? I could use a wider, right, wider pipe, change the pipe to a wider pipe. So these are the possible answers. I will put it here for you to consider the possible answers. So these are the possible answers. Move the storage tank higher, use a longer water pipe, increase the size of the water pipe, increase or means or widen. Maybe I put widen. Widen the width. Use a longer water pipe. Okay, widen. Widen the water pipe to allow more water to flow. Okay, so these are the possible answers. So same thing, I would screenshot this and send to you now. So this one quite simple. You move the water tank higher. By moving higher, you have more GPE. So more GPE will be converted to more KE. Okay, so I scroll down. Okay, next, this is the portable speaker she bring to picnic. So I believe you have seen this speaker before, right? So again, they say there are batteries inside, this one. Batteries in a speaker. So you highlight this. They are new and in working condition, means it's functioning well. Write down the energy conversion when you switch on the portable speaker in the boxes below. So you must understand, what does battery store? Okay. So the first blank is battery stores chemical potential energy. So when you switch on, of course, it's changed to electrical energy. And then because it's a speaker, right, it produces sound. And because after some time, it produces heat. So you spell the word chemical potential, change to electrical, change to sound plus heat energy. Okay, next is after 3 hours of use, Wei-Ling found that the speaker had stopped working. What could be a possible reason? Okay, so the very simply, the reason is because the battery had no more chemical potential energy, right? Or you can say the battery had drained or the batteries were flat. Okay, okay, try to avoid using the word the battery has no power. Okay, so you can use this possible answer. The battery had no more chemical potential energy. That's the best answer because it's related to the question. The batteries had drained. Okay, and the last one, the batteries were flat. So these are the answers. Okay, next, instead of using battery, right, she brought the speaker home and removed the batteries. She then connected it to a power socket. It started working again. So you take note of this one. Connected to a power socket. She used it to play music for 4 hours before switching it off. Why was she able to use a speaker for a longer period? Because before that was 3 hours, right? Can you see? You compare the time. It mentioned like 3 hours using the battery. But now remove batteries, plug into the socket, right? She can play 4 hours. So you need to explain why this additional 1 hour. Okay. So this one, because you see the battery has specific amount of chemical potential, but when you plug into the socket in your house, right, has a continuous supply of what energy? Electrical energy. Okay. So you must mention by connecting the speaker to the power socket, there will be a constant supply or continuous supply of electrical energy. So this answer, by connecting the speaker to a power socket, there will be a constant supply or continuous supply of electrical energy to be converted to sound energy until the power socket was switched off. Because they say before switching it off, so you must say this part, until the power socket was switched off. Okay, so you take note of this. I will screenshot this and send to you now. And then we'll take a short 7 minutes break shortly. Okay, I screenshot this and send to you. So after the break, we come back, we'll do the next set of questions. So you download all the screenshots we are just sent to you. Okay, this part. Okay, we come back in a 7 to 8 minutes time. See you later.